In this video, we're going to create our asteroid field. So that's going to require us to create our asteroid script, asteroid manager script, as well as our asteroid prefab. So I'm going to stub out the two scripts, then bring in the model, create our prefab, and then fill in those files. So jumping into Visual Studio, let's go ahead and create our asteroid script stub. So our asteroid is going to be called asteroid.
Say it isn't so.
Yeah. And I'm just going to inherit from mono behavior, so we're pulling in Unity Engine at the top. Now, as far as the code that is going to go into here, I'm just going to write out our public methods and our public properties, just so people can get a sort of feel for how the public API of our asteroid is going to look. So each asteroid is going to have a public int level. Now, a level is going to be the relative size of the asteroid in a numeric form. And what I'm going to do is I'm going to write a private const int max level and set it to 6. So our asteroids will be between 1 and 6 depending on its size. And that'll determine some of the stuff that happens to it when it gets destroyed. For example, if it gets destroyed, does it spawn additional asteroids? Next thing I'm going to do is I'm going to do a public float distance squared. Now this is going to be the distance from the player squared. And the reason I'm doing distance squared and not distance is it's actually easier to compute the squared distance between 2 points. If you can get away with it, you should always do that operation instead, because to calculate the distance of something you have to get the square root of its distance squared. Since we only need the distance squared, that's all we're going to use. Next up, we need an isVisible flag to determine if this asteroid is visible by the player. We're going to need an isActive flag to determine if this asteroid is actually even active, because we will be creating a bunch of asteroids and many of them will be inactive until we need them. So we're kind of pulling our asteroids together so we don't have to create a million objects all the time. We're going to have a awake method. We're going to have a public void update player location method that takes in the player location. I'm actually going to change the verbiage here. I'm going to say update player position, because position is more commonly used. And the update player position will update these different flags on it, like such as its distance squared and isVisible. Now,
sounds good so far.
Yep. And we'll need an update method. We'll also need a public void init method. Now the public void init method is going to take in the position, the rotation, the direction, the scale, and the velocity of the asteroid. These are going to be computed by the asteroid manager and then set on the asteroid himself, who will use these different values to position himself, scale himself, and move him during the simulation of the game. Next up, we're going to need an activate method and a deactivate method. For activating and deactivating an asteroid. And for now, that's all we need. So this is our basic stub for our asteroid. So let's go ahead and stub out our asteroid manager, which will be slightly simpler because some of his more difficult methods are private and not public. So I'm going to write an asteroid manager. Now the asteroid manager himself will be a mono behavior. He is going to have a public asteroid prefab. Now, if you wanted to do multiple asteroids and randomly select one of them out of a list of prefabs, you could do a public asteroid array if you wanted to. He's going to have a public int max asteroids, which is going to be the maximum amount of asteroids in his asteroid pool, and then a public int max visible asteroids. These will be the amount of asteroids that are always visible by the player. He is going to have a public void awake method, a public void start method, a public void late update method, and then, as far as his public methods, that's it. So we're going to fill out some more private methods and some private data here in a moment, but I just wanted to get these scripts public APIs out of the way to give people an idea about how we're going to be using them, and so that we can jump into Unity and start instantiating these objects so we can test them as we fill in their implementations.
Sounds like fun.
Alrighty, so let's jump back into Unity, and I'm going to open up my Scratch scene. So I'm going to go to Scenes, Garbage, Scratch. Now what I'm going to do is I'm going to open up my Models folder, and I'm going to bring in my asteroid. So coming over here, I'm going to pull in asteroid.fbx into my models. Now I am going to go ahead and remove materials out of that folder that was created, and instead I'm going to create a new folder called asteroid. And I'm going to pull in asteroid.tga into that. Then I'm going to create a material in here. So I'm going to click over here, create material called asteroid. Now the material that I'm going to use for my asteroid is actually going to be a transparent diffuse. That's because I want the asteroids to actually fade in when they're created, because a lot of the times the asteroids will be created in the player's field of view. And so because of that, I want to give it a nice transition effect for them being instantiated. Next up, I'm going to drag and drop the asteroid texture onto that material. So now I have my material brought in. I'm going to go ahead and create my asteroid prefab. Now my asteroid prefab is going to start off as a simple empty game object. So I'm going to go to game object, create empty. I'm going to make sure to center him in the origin. And I'm going to rename him to be asteroid. As far as the components I'm going to attach to him, I want a mesh filter. The mesh filter is going to point at, I believe it got imported as psolid3 as the name.
Yeah, I don't remember that one being there.
Yeah, that's what the asteroid got brought in as. Then I need my mesh renderer. My mesh renderer is going to have a material, which I'm going to click, drag, and drop my asteroid onto its material. And hey, look, now we have an awesome asteroid.
Cool. Where'd you get that?
They're just lying around.
Oh, all right.
It works.
Yeah, I was just like, I didn't make that. I wonder where he got that.
So then what I'm going to do is I'm going to click and drag the asteroid script onto my asteroid object. Finally, I'm going to turn this into a prefab by closing out my folders, opening up my prefab folder, and clicking and dragging asteroid onto my prefabs folder. So I now have an asteroid prefab that I can attach onto an asteroid manager, which has most of itself already pre-set up with its script and its mesh filter and render. We'll be readdressing this prefab later down the road when we get collision, but that isn't until later.
Cool. All right, we have something to shoot at.
Yep. So now what I'm going to do is I'm going to jump back into game test. This cube's bother. I won't delete them yet. What I'm going to do now is I want to create my asteroid manager. Typically what I do is I create a game object, an empty game object, and I call it managers. And then on managers, I add a game object for each one of my sort of manager game objects, things that don't really have an actual physical representation to them, but still perform logic that's important for the game. So I'm going to create another empty game object, parent it to my managers, and I'm going to rename this asteroid manager. And then I'm going to go back to my code folder and click and drag asteroid manager onto my asteroid manager game object. Now that I've done that, I need to go ahead and configure him to an extent. I'm going to set his max amount of asteroids to 400 and his max visible asteroids to 200. The final thing I have to do as far as configuration is concerned is I have to set his asteroid prefab to the prefab that we just created. So going back into my project pane, I'm going to go into prefabs, click and drag asteroid onto asteroid prefab, and now we have hooked that up.
Cool. That's a lot of asteroids.
Yes.
Sure about that? All right.
I'm positive about this.
Okay.
Okay, so now let's go ahead and go about implementing our asteroid manager and our asteroid. Unfortunately, we're going to have to write these kind of at the same time in order to well, get the effect that we're going for, because they kind of depend on each other. So let's start off with our asteroid manager. Our asteroid manager is going to have a private list of asteroid. Not surprisingly, called asteroids. Now, of course, because I'm using the list of T, I have to bring in system collections generic up at the top. In addition, the asteroid manager is going to have a reference to the player. So I'm going to say private player player. He needs to know the position of the player so he can tell the asteroids to compute their distance between themselves and the player and whether or not they're currently visible.
Alrighty.
Okay, so next up on our awake method, I am going to instantiate asteroids. Come on. And I'm going to locate my player. So I'm going to say var player equals player find object of type of player. That will find an object in the scene of type player. Find object of type is a particularly slow method, but that's fine because it's only done once at the start of the game. Once I have that reference, I store it in a field.
Alrighty.
So next up, I have to go ahead and create all of my asteroids. So I'm going to, on my start method, I'm going to loop through all of my asteroids that, well, I can create, and create all of them, essentially. So I'm going to say for var I equals 0, I smaller than max asteroids, I plus plus. Then I'm going to say var asteroid equals asteroid instantiate asteroid prefab. Then I'm going to say asteroid.gameObject.name equals asteroid blank, so asteroid I, so asteroid, basically it'll be asteroid 0 through 499. Then I'm going to say asteroid.deactivate. Then I'm going to say asteroids add asteroid. So essentially what we're doing is we're constructing our 500 asteroids and deactivating them all so that we can use them when we update.
Okie dokie.
Okay, so what I have to do now is I have to write my late update method. Now there's a reason why I'm doing late update, not update. There are a couple update methods inside of Unity, and the update method will be typically fired, it's pretty close to one of the first methods that will be fired on mono behaviors. The late update will always be invoked after all of the updates have been invoked on each one of the mono behaviors. Why is this important? Well, it's important because my player controller class and my player camera class modify the position and rotation of both the player and the camera, both of which are very important for determining if an asteroid is in the view. So late update is a method invoked by Unity. My late update method is essentially going to loop through all of my asteroids, determine how many are visible, and then if how many are visible is less than the amount that should be visible, it'll reactivate or reuse old asteroids that have been deactivated. So what I'm going to do is I'm going to say var total visible equals 0 for each var asteroid in asteroids where, now bringing in where will pop in a using statement for system.link at the top, where a goes into a.isActive. So we're looping through all the active asteroids. Then I'm going to say asteroid.update player position, player transform position, telling each asteroid to recalculate whether or not it's visible. And then I'm going to say if asteroid.isVisible, then total visible plus plus, which means we found a visible asteroid, so we don't want to do anything with it. Next up, we want to loop through all of our asteroids again in order to determine if they are active or visible or blah, blah, blah. Well, actually, the code speaks for itself, so let me go ahead and just do this. So say for var I equals 0, I smaller than asteroid, or sorry, asteroids.count, I plus plus. I'm going to say var asteroid equals asteroids at I. If the asteroid is active and the asteroid is visible, then continue, because we're not interested in this asteroid. It's visible and it's active. However, if it's active and the asteroid's distance squared is smaller than 50 times 50, then continue. So what is this doing? Well, this is saying if the asteroid is active and it's visible, then don't do anything. If the asteroid is active and its distance is less than 50 units away, then don't do anything. However, if the distance is greater than 50 units away, then do something. We haven't written that something yet. Now you'll notice that I said asteroid.distance squared is smaller than 50 times 50. That's because it's easier when comparing distances to compute the square magnitude or squared magnitude of a vector and then compare it by squaring the right-hand operation or the right-hand operand. Now in this case, the right-hand operand is 50 times 50, which I do that just for convenience. It's easier for us to see that we are trying to see if it's less than 50 units away, so it's easier for us to see that it's less than 50 times 50 units away if we're comparing squared distances. Again, this will be pre-computed by the compiler, so there's no performance penalty of writing out math like this.
Alrighty.
So
my head hurts.
So next up, what we got to do is I'm going to say if total visible is smaller than max visible asteroids, then repurpose this asteroid. So I'm going to say activate asteroid. Then I'm going to say total visible plus plus. Otherwise, asteroid dot deactivate. So what I'm saying is if the amount that is visible currently is smaller than the max that should be visible, and this asteroid is either not visible or it's further away than 50 units, then reactivate it. Now the activate asteroid method will basically take this asteroid, pick it up, and place it somewhere in front of the player, and then increment the total visible. If we've exhausted the total visible, then we simply deactivate the asteroid and just let it sit there until we need it again.
Alrighty, that makes sense.
So that is the late update method. So now what we have to do is we have to create our activate asteroid method. Now this won't be the final implementation for our activate asteroid method, but it will work for our purposes for this video. I'm going to write activate asteroid. Now the activate asteroid method, the first thing it's going to do is, well, activate the asteroid. Then it's going to calculate the rotation, direction, and scale and velocity of an asteroid. So I'm going to say var rotation of the asteroid is going to be, now this is where things get kind of, well, the rotation itself isn't that weird. This one should be pretty straightforward. I'm simply going to say random.range 0 to 360. However, I'm going to do 0f to 360f so I get the float version of this method and not the integer version of this method. So the rotation is completely randomized on all three axes between 0 and 360 degrees, which is fine. Then we need our direction. Our direction is simply going to be random.range 0f to 1f, because it's going to be essentially a normalized vector. Or that's what it's going to return anyway.
Alrighty.
Then we need our scale. Now our scale is going to be fun. I want there to be two different scale calculations depending on a particular probability. So what do I mean by that? Well, I want about, let's say, roughly 30% of the time, I wanted to create a really, really big asteroid, and 70% of the time, I wanted to create normally sized asteroids. So how do I do that? Well, we can do that with a simple ternary. I can say random.range 0f to 1f is greater than 0.3f. If that's true, return a new vector 3, which is random.range 25f to 90f for each three of the components. If this condition is false, that means this is going to happen roughly 70% of the time. I want to do random.range 110f to 160f. So about 70% or 30% of the time it'll be really big, 70% of the time it'll be rather small. There we go.
Very good. Okay.
Then I need to compute the velocity. Velocity will simply be random.range 15f to 25f. And finally, I need to compute the position. So this is where things get fun.
How are we going to do that?
Well, what I need to do is,
to make it constantly random.
if we look at our main camera, we'll see our view frustrum. Right?
Yep.
A frustrum is a shape that looks like a pyramid with the top cut off. Now, the small part of the frustrum is our near clipping plane, and the far part of the frustrum is our far clipping plane. So, what I want to do is, by definition, any point within this frustrum will be in view, right?
Right.
So, what I'm going to do is I'm going to kind of cheat. I'm going to pick a random number in viewport space, and then I'm going to project that random number in viewport space into the frustrum. Now, this won't actually give us a proper distribution, unfortunately, because what's going to happen is, by the way, when I say viewport space, I mean a number between 0 and 1 in both x and y.
Okay.
So it's homogeneous space. It's where you have like 0.5. 0.5 is the center of the screen, right?
Yep.
So if I compute a number between 0 and 1 for both x and y, and then I pick a number between, let's say, 20 and 500 for the z coordinate, I can then project a ray from the beginning of my frustrum to that point in the distance. Now, like I said, this will not result in a uniform distribution. What do I mean by that? Well, I mean that if you ran this calculation millions upon millions of times, not every single part of the frustrum will be consumed. The reason that is because points that are closer are more probable to be hit than points that are further away. But that's fine. I don't really care about that. This is an approximation, and for the purposes of this game, this approximation is perfectly fine.
Alrighty.
So you kind of understand how I'm getting a random point within this frustrum?
Yep.
Okay. Now, when I said random point within this frustrum, I kind of lied. I'm actually going to get a random point within kind of the edges of this frustrum, so that some asteroids get generated outside of it, which gives the, just slightly outside of it, which gives a better feel for the game, so it doesn't look like they're all popping out of nowhere.
Okay.
So to calculate that, I'm going to say var position equals new vector 3. Or sorry, what am I doing? I'm doing something. Camera dot main viewport to world point. So viewport to world point. Like I said, we're working in viewport space, and then we're going to convert that into world point. So I need to pass in a x, y, and z. So my x is going to be random.range negative 0.5f, 1.5f. The y coordinate is going to be negative 0.5f to 1.5f. The z component, however, is going to be a little bit more complicated. I want to say random.range 0 to 1, or 0f to 1f, to make sure I'm using the float version of this method, multiplied by 300 plus 150. So what's this going to do? Well, this bit is going to compute a number between 0 and 300, and then I'm going to always add 150 to it, which means that the asteroid will appear between 150 and 450 units away from the player.
Okay, that makes sense.
Okay, so now I have my rotation, direction, scale, velocity, and position. I can now do asteroid.init, passing in my position, rotation, direction, scale, and velocity. Okay, so let's jump into the asteroid, and let's implement this just enough to where I can see it kind of working. So I'm not going to make them move quite yet, but I do need to implement a few of these methods in order to get this to work right. So inside of my wake method, I'm not going to need anything quite yet, so I'm going to jump down to the update player position. Now the update player position method is responsible for A, determining if we are visible, and B, determining the distance squared between us and the player's position. So to determine that if we're visible, it's actually a very easy calculation to make. I can simply do camera.main world to viewport point transform dot position. Then I can say is visible equals if the point.x is greater than negative 0.5f and and point.y is is smaller than 1.5f and point.y is greater than negative 0.5f and point.y is smaller than 1.5f and point.z is greater than 0. So if it fits within this rectangle, then that means that we are visible.
Alrighty.
Then I calculate the distance squared simply by saying distance squared equals transform.position minus player position dot SQR magnitude. Now SQR magnitude is the squared magnitude, which is the magnitude of this vector, but it's squared because the final operation to finally compute a magnitude is the square root operation, which is expensive. So this is the squared magnitude.
Okay, that makes sense.
All right, so let's not worry about update because that has to do with our asteroid moving, which we're not worried about yet. Now let's go ahead and do our init method. Now our init method is going to do a couple different things. We're not going to worry about calculating our level just yet, but we are going to say transform.position equals position. Transform.local Euler angles equals rotation. Transform.local scale equals scale. Then we're going to say is visible equals false. Just to initialize that, reinitialize it so we're not saying that we're visible when we're not. Then we need to implement our activate and deactivate. Now in this, we will be doing some fun stuff with our fading in a moment here, but for now all activate does is set is active to true, and it sets GameObject.setActive to false, so that our GameObject is inactive, which makes sure that we're not rendering it. Next up, the activate method will set isActive, activate should set isActive to true. How did you miss that, Steve?
I don't know. I miss everything.
Anyway, the point is that they just do the same thing but in reverse for now. But this should actually be all we need to see some asteroids on the screen. And now look, no matter where we go, we see asteroids. Now what I can do is we can actually see, if I make this the scene view and the game view visible at the same time, we can see how our asteroid generation is happening. See as I rotate around?
That's very cool.
Okay, so everything is indeed working. So, but you'll notice that they do pop into place, and that doesn't look very good. But we can actually fix it by cheating a little bit, which 90% of game development is cheating.
All CG is sleight of hand.
Yep. By applying a really simple fading effect. And by doing that, it'll become a lot smoother and more palatable for the player. So to do that, let's have that be the first thing that we do on our asteroid, because we haven't completely fleshed out our asteroid quite yet. To do that, we need to set our alpha. And our alpha is going to be lerped on its update method. So what I'm going to do is I'm going to write a private float alpha alpha for our alpha channel. Now, our alpha channel will be set to 0 when we activate. However, in addition to setting alpha to 0, I will also reset the renderer material color to new color, and the color that we're going to be setting to, if you looked at our material, is going to be we look at our color, it's just pure white. So we can say 1, 1, 1, 0. Now the reason I'm doing this is so that after we activate an asteroid and the update method might not be called in the same frame, we want to make sure that it always comes in with a 0 alpha. Now what we have to do is in our update method, we have to go about making our alpha go from 0 to 1, which is actually very straightforward. Simply say if alpha is less than 1, then alpha equals mathf.lerp alpha to 1 time.delta time times 10, which is an arbitrary number I decided on. You can increase or decrease this number depending on how fast you want them to fade in. Then I'm going to say if alpha is greater than 0.9 or 9.9f, then just set alpha to 1. Then set render material color to equal new color 111 alpha.
Okie dokie.
So coming back into Unity, we should see our asteroids fading in. I don't know if you can see that on the video or not, but
yep,
it's kind of
it's easiest to tell if you look right out in front of the ship.
Yep, but it's definitely a lot nicer of an effect. Okay, so there's a couple more things we have to do with our asteroid. We're gonna go ahead and do the level computation, and we're also going to make our asteroids move. So to do that, I need some more data. In addition to storing my alpha here at the top, I also want to store my velocity. In addition to the velocity, I need to be able to store my vector3 direction to know which direction I am moving in. So now that I've done that, I can go into my init method and I can store these variables. I can say velocity equals velocity and direction equals direction. Using these two values, I can go into my update method and I can simply say transform.translate, and I want to translate in direction times velocity times time.delta time. Coming back into Unity, we should see that our asteroids are now indeed moving around the screen. And as they go out of view, they get deactivated, and then they get regenerated to be inside of the player's view.
Very nice.
So now let's go ahead and add in our computation for our level. Because remember, the level is going to be used to determine the what happens when an asteroid gets destroyed, or how many sub-asteroids it creates. So the computation I'm using is fairly arbitrary. It's just going to be level equals int mathf ceiling on scale dot magnitude minus 25f divided by 255f times max level minus 1 plus 1. So that should give our asteroids a nice little level for them. To test this, we can go ahead, so I'm going to write an onGUI method just to test our level computation. I'm going to remove it immediately after, so don't think that this has to stay there. But I'm going to say public void onGUI, then I'm going to say GUI.label, say var position equals camera.main.world to screen point, transform.position. I'm going to say var label, the rect position is going to be new rect, position X, position Y, width of 200, height of 50, and then say level.toString. This is just for testing purposes. That'll print the level of an asteroid over it, so we can get kind of a feel for how that calculation is working.
Okay.
So if I jump back into Unity, I can see that we have, some 6s, we have some 3s, and I'm not. I have my y backwards. I need to do screen dot height minus position y. Sorry about that. I always mix that up. I don't know why. Anyway, so we have some threes, and we have lots of threes and lots of sixes, and a couple twos and a couple fours. So we can kind of see that they are indeed relative to the size of that asteroid.
Okay.
So I'm kind of happy with that distribution, but if you aren't, you are more than welcome to play around with the computation that bases the level off of the magnitude of the scale.
Alrighty.
Okay, so removing the on GUI method, we've pretty much written most of our implementation for our asteroids, with the exception of making them explode. Same with our asteroid manager. Pretty much all of this is done except for the bits that determine when an asteroid should spawn subasteroids. So we will be doing that in the next video.
All right. See you then.